Hi everyone, welcome to ICPC, and today we will walk through Leetcode number 41, which is the first missing positive. Given an array of integers, return the smallest positive integer that's not in the array. For example, 3, 4, -1, and 1. What is the first positive number? Yeah, that's right. It is 2. Because if we sort this array, we will see we have -1 is not a positive, so we don't care. 1, 3, and 4. Therefore, 2 is missing. What is a naive idea of solving this problem? Obviously, we can sort it, which will take n log n. But the time complexity should be O(n) because the length is 10 to the power of 5. What if we use a bucket sorting algorithm? So to find the first positive element, we give a spot for each of the element from 0 to 10 to the 9. For example, let the spot 1 to be 1, spot 2 to be 2, all the way to 10 to the 9th. Now we can loop through the array once. When we see 3, we will put 3 here, mark this as true. When we see 4, we mark spot 4 to be true. When we see -1, we neglect it. When we see 1, we mark 1 as true. So this first pass, we will mark all the elements. And the second pass, find the first missing spot. We mark all the spots. Well, during the second pass, we will correctly spot 2. What is the time complexity? It is O(n), right? Because we loop through n elements. However, the second pass will be O to the 10 to the 9th because there are 10 to the 9th spots, right? What's the space? The space complexity, we need this accelerate array of 10 to the 9th positions. So it's 10 to the 9th. What if we want the time complexity to be O(n), but the space complexity to also be O of 1 or O of n? How can we do that? Let's erase this example. Idea 1 has a space, has a time of O to the 10 to the 9th and space of 10 to the 9th. What if we want a better idea to achieve time of O(n) and space of O(n)? Can we do that? Observe that the first missing element must be in the range of 1 and n plus 1. Why? Because there are at most n elements, 1, 2, 3, 4. So if it's a missing element, it must be in this range, right? For example, if we have 4 elements, such as 3, 4, -1, and 9. So 9 is outside of this n plus 1. So the first element must be within 1 to 4, which is 2. So given this observation, can we shrink down our accelerate array from 10 to the 9th into, and now let's define our spots array to be a length of just n. The first position will represent a 1, second to be 2, third to be 3, and fourth to be 4. Now, let's still use the 2-pass method. First, we loop through all the elements in the array and mark the spots. 3, we will mark 3 as true. 4, we will mark 4 as true. -1 is outside the 1 and n plus 1 range. We don't regard it. For 1, we mark 1, spot 1 as true. And the second pass, we will correctly identify the spot of 2. What's the time complexity? O(n). And what's the space complexity? It's O(n) as well, this auxiliary array. Now, the most challenging part is if we want the time complexity to be O(n), but space to be O(1). Is there a way to achieve this? Now, to achieve a space of 1, we will need to rely on the original array and add the info to the original array. And this info will be whether the spot is marked or not. For example, we still want to use the spot array spots such that we mark, so each position will indicate or represent the n elements. So at position 1, this should still preserve the information of having true. And elements 3 and 4, we also want to have this to be true, meaning that we have those elements in those spots. So how to merge this true info to the original array? Consider this trick. Let A of AI mod n plus equal to n. What does that mean? Let's give an example, looping from the from the first to the last. To be more convenient, let us add a spot of 0 in the front so that the modular operation can be more clear. So index 0, we have the element 3. 3, let's say I equals to 0. The element is 3. Here is I 0, 1, 2, 3. We will set A of 3 mod n to be equal to n. So what's 3 mod n? N is 5 here. We'll have the original element -1 plus n, right? Because the original array is, we just copy it down, 3, 4, -1, and 1. So this is the original array. Now for I equals to 1, we will retrieve the element 4 mod n. So n is 5 here because we appended a 0. So 4 mod 5 is still 4. And the 4th place, we will increase it by n. So this will be 1 plus n. Now for I equals to 2, the element is -1, which is neglect. Now for I equals to 3, the element is 1. So A of 1 mod n plus equals to n. 1 mod n give us 1. And now we add n. So it becomes 3 plus n. What is the benefit of this method? This modular operation allows us to extract the original element information. And if we just set this block to be true, it will erase the information of 3, the original element's information. So this modular way preserves the original value and also the frequency of whether this spot has a plus n here. So in the second pass, we just check whether an element doesn't have a plus n. What is the time complexity? It's still O(n). And what's the space? It's O(1), because we don't need any extra space. We just append the original array. So it's O0, like no extra space wasted. Thank you for watching.